Hey everybody, how's it going? My name is Attila, and in this video I will kick off a new series about PG Vector. And I'm specifically trying to make this useful for developers, so developers who are trying to build AI applications and they love Postgres, they want to keep using Postgres, and so they want to use PG Vector for storing vector data. So because this is the first video, I just want to lay some groundwork and explain some basic concepts. And those concepts in this video will be vector data and similarity search. So we are going to discuss those two today. So first of all, what is a vector? In this context, vector is the same thing as an embedding. All right, so I might say embedding or I might say vector. In some cases, it's going to mean the same thing. And it's really just an array of numbers. So if I say embedding or vector, it's going to be an array of numbers. As you can see on this example, the number of items in the array will depend on the embedding model. So how many dimensions the embedding model has, that will dictate the number of items in this array, but that's for another video. What's important for now is that this vector will represent something. Now that something could be a sentence. So Postgres is a powerful open source relational database. That sentence can be vectorized and turned into an embedding, and then you can store that embedding in a database. You can also vectorize an image. So you can just turn an image into an array of numbers and then do similarity searches on the image. And then you can get creative with it. You can vectorize a whole book. You can vectorize a page in the book. You can vectorize sentences in a paragraph. Now, why would you do that? Like, why does it make sense to store data in vector representation? So to give you an example, let's say you are storing this image in a database. Normally, if we are not talking about vectors, you are going to store this image by the URL. And what I mean by that is that if you store the image by the URL, you will query it by the URL. So if you want to get the image, you need to query it by the URL, and that will retrieve the image. Now, what if you want to build a more useful application or an application that involves AI? You will query not by the URL, but you will query by semantic similarity. And what I mean by that is that you can say that, hey, get me the image that contains a dog. And the database will then give you an image that contains a dog. And this is possible because of vectors, because of the vector representation. So let's talk about semantic similarity. So let's say you have to find the most similar images to the one image on the left. So if you look at this, it's fairly easy to say which image is similar and which image is not similar at all. So for example, the sunflower image is obviously the least similar to the original image because it's not an animal, it has nothing to do with animals. Now, on the other hand, the other two images both include dogs, and the original image also includes dogs. So those are the more similar images to the original image. Now, for you, it's easy to decide because you can just look at it and you understand what a dog is. A computer doesn't understand that by just looking at the picture. But if you store the images in vector representation or in the form of a vector, then now you can actually know what the image contains. So the process is basically this. You create the embeddings from the data. So you have all the images, including the original image and your other images, and then you turn these into vector representation. So you will have a bunch of arrays with a bunch of numbers. You store it in a database. All right, so you have these vectors, you store it in a database. In this example, we are using Postgres and PG Vector because the core or the video series is about PG Vector. So we are storing everything in PG Vector, and then now you can run semantic searches. So you have your database with all the embedding values or the embeddings. Then you are running this or some similar query. This is basically a semantic search. And then the result will be the top 3 most similar images, ordered by similarity. And this is using semantic search methods under the hood. So let's quickly explain this query. So if we look at this query, the first thing that you can notice that you might not be familiar with is this operator. So this operator is basically the operator that PG vector gives you. It's not part of the vanilla Postgres. So you can only use this operator and other similarity methods if you install PG vector. And this is going to calculate the L2 distance. L2 distance is a similarity method or a way to calculate the distance between 2 vectors. There are a lot of other ways to do this. There is L1 distance, there is dot product, cosine distance is another method. These are all different ways to calculate the similarity or the distance between 2 vectors. And the reason this is useful, because this way you can kind of sort all the results or all the items in your table based on similarity. And then because of limit 3, it will just give you the 3 most similar items. And that is how it works. Now let's look at the other parts of the query. So we have this embeddings table. Again, this just contains the vectors. And then we have the original image, or in this case, the image that we use in the query. That needs to be a vector as well. So you can only compare vector to vector. So what you would usually do in practice is you have your table full of embeddings, and then when you have an image in this example that you want to search, you just turn that image into a vector on the fly. So you do that, and then you execute the similarity search, which will basically order the embeddings based on similarity and give you the most similar items. All right, so that's it. I hope that made sense. Let me know if you have questions in the comments below, and I see you in the next video of this series.